name is Pete Young. Today we will be discussing the space travel behind Star Trek, specifically the warp drive, and everything that goes wrong with it. And basically we're going to discover whether man can go to infinity and beyond, where no man has gone before. Alright, so the main thing behind Star Trek is interstellar space travel. The definition of this is manned or unmanned travel between stars. Now, why would we care about different stars? Why would we want to go from our sun to the next star over? Well, planets revolve around stars, so if we can get from our star to the next one, we can most likely get to the planets that are around that star and discover life or other species on those planets. Now, what is the first problem with space travel? Well, you have a unit called light year, which is the distance that light travels in a year, which is 9.46 times 10 to the 15th meters. That's an incredible distance. It's unfathomable. And the speed of light is 3 times 10 to the 8th meters per second, which, when you're talking about long distances like this, that's nothing. You're not going anywhere in a year. Now, our nearest star is Alpha Centauri A, which is 4.3 light years away from our own sun, which by modern technology, by the modern space shuttle, it would take you 164.82 millennia to get there. Not centuries, millennia. Now, real quickly going over the speed of light. Light actually comes from an alternating of electric and magnetic fields to produce what is called an electromagnetic wave, which we just commonly refer to as light. And there are two constants in electromagnetism. One, the electric constant, the other magnetic permeability, which are given by the values epsilon naught equals 8.85 times 10 to the negative 12 farads per meter, and mu naught, which is 4 times pi times 10 to the negative 7 henries per meter. Now, this equation is given by general physics, that if you take 1 over the square root of the product of these two constants, you'll get the speed of light, which we just round to 3 times 10 to the 8th meters per second, because that large number it's so close, any difference is negligible to us. Now, Star Trek, the warp drive, works on this equation that the producers, or writers of the show, came up with. That's velocity equals the speed of light times a warp factor cubed. Now, whenever you're at warp factor 0, not moving, warp factor 1, removing the speed of light, warp factor 2, 8 times the speed of light, and so on. Now, this is all powered by warp core, which collides antimatter with matter to create energy that is needed to power everything on the ship. This will give off massive amounts of radiation, hence, spoiler alerts, why Spock dies at the end of Wrath of Khan. Now, what is the problem with this idea? Well, there's a natural balance of antimatter and matter. Whenever the Big Bang occurred, for some reason, in our universe, there was not an equal balance of the two, and there would have been a universe. First, with us, there's almost no antimatter and an overabundance of matter. And so you do not have a source in which you can obtain that much antimatter needed. Because if you listen to the intro of Star Trek, it's a 5-year voyage. Today, with technology, we can barely hold antimatter for a couple seconds. You're not going to be able to hold it for 5 years, let alone even have enough to hold for 5 years. The other problem is there's too much radiation. The most any known material can really hold radiation today is 95%. Eventually, everything's going to leak. And if you think about it, 5 years in space, billions of collisions of antimatter and matter per second, we do the math, it's more radiation than any person could handle. Now, the other problem is dealing with relativity and mass. Everyone knows Einstein's famous equation, E equals mc squared. What you may not know is that's not the full equation. The full equation is E squared equals pc squared plus mc squared squared. Now, if you derive this in a certain way, you'll get the equation V equals speed of light times the momentum times speed of light over the energy. Well, using all these equations, you can determine that the speed is never going to actually reach the speed of light if you have mass. And I have a video here that will better explain it for you guys.
E equals mc squared may be the most famous equation in the world, but what you might not know is that it isn't the whole story. It just describes objects that have mass and that aren't moving. The full equation is E squared equals mc squared. squared plus p times c squared, where p represents the momentum of the object in question. This might all seem a bit confusing, but in fact you can draw it as a right triangle with sides e, mc squared, and p times c. And just use the Pythagorean theorem, a squared plus b squared equals c squared, to give you the equation. Also, from here it's clear to see that for an object that isn't moving and thus doesn't have any momentum, and thus p is 0, we get back our good old friend E equals mc squared. On the other hand, if the particle in question is massless, like light, then mass is 0, and we get E equals p times c. This tells us that the energy of a massless particle, like a photon of light, is the same as its momentum, up to a factor of the speed of light. In fact, the closer the energy of something is to p times c, the closer that something is to behaving like light. I mean, look here, this tiny little bit of mass is hardly mass at all. Anyway, as an example, an object's velocity is equal to the speed of light times the ratio of the object's momentum to energy, or pc over e. If your momentum increases, p times c gets closer and closer to equaling your energy, so their ratio gets closer and closer to being 1, and your speed gets closer and closer to light speed. But because of that tiny little bit of mass, the momentum side of the triangle will always be a little bit smaller than the energy side. No matter how hard you try to increase your momentum, it never quite gets to the point where p times c equals your energy, and thus your velocity can never quite reach the speed of light, all because the hypotenuse of the right triangle is longer than its legs.
Alright, so as you guys see, we as humans have mass. It's an undeniable fact, humans cannot have mass. If you look at the size of a starship like the USS Enterprise, well, that's going to be hundreds of thousands of tons of weight. So if you're just looking at it from a normal physics perspective, there's not even any way remotely close that you'd be able to get a spaceship to the speed of light. Now, of course, whenever you actually look at warp drive, what it's going to do is create a bubble that morphs the space-time, and you're going to move in a different version than normal physics would do. But if you're following normal physics, there's no possible way to get even remotely close to the speed of light. So is it possible to warp? Well, the biggest problem is you're going to have to find a way to make yourself massless. If you can do that, then you can travel at the speed of light. Once you do that, you can figure out some technology to create a warp drive. If you have the intelligence to do that, why the heck are you going to college right now? You should be somewhere else. If you can do that, the other problem is ships aren't going to have the stability to travel at such high speeds that they're going to start wanting to break down. So you're going to have to also create some technology to keep your ship from wanting to fall apart once you hit the speed of light. And once you do all that, you can boldly go where no man has gone before.